Well, welcome back, everybody, to another exciting episode of Pre-Calc Notes. Let's go. So today we're going to do all 6 trig functions. Really, all you need to know is sine, cosine, and tangent, and then from there we can just flip them over, right? So you don't have to learn a whole bunch of new stuff. So SOHCAHTOA, if you know that, that's all you need to know. Well, besides which one goes with which, and I'll show you some tricks here. So for this, SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And what these trig ratios are is just a relationship from the sides. That's all it is. Just compares the length of two sides, and basically it's based on the angle location. So the first thing you have to do, of course, is find which angle it is you're talking about. Directly across the triangle, this is your opposite side. The one right next to it you can see is the adjacent side. And of course, across from the right angle is the hypotenuse. The hypotenuse is always the longest side because it's opposite the biggest angle. Now, as far as your reciprocal functions go, because you kind of learned it in this order, sine, cosine, tangent. You learned cosine as the second function. So second, the abbreviation, if we think about what it looks like when you abbreviate it, it looks like SEC, right? Second. Like, wait a sec. And that is actually the abbreviation for secant. So cosine is second, and so secant goes with cosine. Cotangent, you won't probably ever get that wrong because it matches tangent, but cosecant is a little hard. So cosecant actually goes with sine, which doesn't have a lot of, obviously, similarity in the words. But secant is second, and cosine is second, if that helps you. So now for the reciprocal functions, it's just that. We just flip them over. So sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Secant, again, second, is hypotenuse over adjacent. And then cotangent is adjacent over opposite. And again, you don't really need to spend any time remembering those as long as you know sine, cosine, and tangent. So technically, cosecant is really 1 over the sine. Now, when we don't know the angle, we use this symbol theta. It's like saying x is the universal number, theta is like the universal angle. Secant is 1 over the cosine, and cotangent is 1 over the tangent. You don't just have these words. Make sure that there's an angle after it. Don't just say secant. Secant what? Like secant theta, secant 50, tangent. Don't just say that. Make sure it has some sort of angle after it. If you don't know the angle, use theta. So we're going to use the triangle to come up with all 6 trig functions. It doesn't have to really be hard work. Just basically reading the triangle and writing down the fraction. So you want to start with, well, where is your angle? And this is the angle we're dealing with. And across from that is the side opposite. So there's our official opposite side, which makes 5 adjacent, and of course 13 is the hypotenuse. All fractions have to be reduced, no radicals in the bottom. So for sine is opposite over hypotenuse. So this is 12 over 13. Cosecant would be the reciprocal. It's as hard as it is. It's really it. Just go with the sign and just flip it over. Cosine is adjacent over hypotenuse. So that's 5 over 13. And then flip that over. 13 over 5. Tangent, opposite over adjacent. So 12 over 5. And we flip this over. We get 5 over 12. None of those fractions needed to be reduced. So they are good. In problem number 2, you can see we're missing a side. In order to find the third side, you would have to use Pythagorean theorem. So this is 6 squared plus 6 radical 3 squared equals x squared. I probably should not put that right there. I'm just going to move this so that I can actually write on my triangle. So we have 6 squared plus 6 radical 3, all of that is squared, equals, I'll just call it x squared. So 36, 6 radical 3, this is 36 times a plane 3, so that's 108. When you add those two things together, we get 144. Oh, and the square root of that is 12. So for sine, we have 6 radical 3 over 12, but that's got to be reduced. So we reduce this, and so it's radical 3 over 2. Now, when you go to flip that over, I would flip over the reduced form. Just flip over the one everyone looks easier. So I'm going to flip that one over. You could flip over any one of them. It really doesn't matter. If you want to flip over the 12 over 6 radical 3. The problem is the radical 3 is on the bottom no matter what you do. So I'd rather do 2 over radical 3 and then rationalize it. So you get 2 radical 3 over 3. Remember, you cannot have a radical in the denominator. Cosine. I guess I probably should have done this first. This is opposite. This is adjacent. This is hypotenuse. So we're dealing with 6 over 12, right? Adjacent over hypotenuse. So that's 1/2. To flip that over, of course, that's nice and easy. And for the tangent, we have 6 radical 3 over 6, which is just radical 3. Now, when you flip over radical, it's 6 radical 3 over 6. Yeah, so it's just radical 3. And then when we flip this over, remember, this is radical 3 over 1, so we get 1 over radical 3. So you got to rationalize it. So it's radical 3 over 3. Now here, we don't have a triangle. It doesn't matter how you draw your triangle. So it's a right triangle. I'm just going to draw my right triangle, super basic. That's my right angle. Tangent stands for opposite over adjacent. We'll pick a corner to be your angle. I'm going to pick this corner. So this is my opposite side. So that means this has to be the 7. This is the adjacent side, which means that has to be the 24. It doesn't matter where you put the theta. It just can't be the right angle. So however you want to draw your right triangle, you can put the theta anywhere, and it won't matter as long as you keep opposite over adjacent. So now we're going to do Pythagorean theorem. 49, that's 7 squared. 24 is actually 576. This works out to be 625, which is a perfect square. So the hypotenuse is 25. And now we have exactly what we need. So we're ready to go. So again, we're going to go opposite. That's our opposite is 7. So we have 7 over 25. Flip it over. Adjacent is 24 over 25. Flip that over. Tangent they actually gave us. I'm going to still write it in there. And then we flip that over for cotangent, 24 over 7. Now for this triangle, we don't have much to go on. We just have a number. Remember, every number can be put over 1. I don't know secant, but I know that cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. So I'm going to draw my triangle again. Here's my theta. That's opposite. This is adjacent. So hypotenuse is 4, adjacent is 1. Pythagorean theorem, 1 plus x squared equals 4 squared. So we get x squared equals 15. So it looks like this side is the square root of 15. So sine is opposite over hypotenuse. So radical 15 over 4. When we flip that over, we get 4 over radical 15. We got to rationalize it. So it's 4 radical 15 over 15. Cosine, adjacent over hypotenuse. That's 1/4. Of course, we knew that already because the secant's 4. And tangent, radical 15 over 1. So we'll just call it that. And then this, of course, is 1 over radical 15. We flip it over, and we have to rationalize this. So we get radical 15 over 15. Now the last little bit here. Special right triangles. These are super important because this is the unit circle. 30, 60, 90. Across from the 30 is the smallest side. So I'm just going to call that 1. Just because that's the smallest number I can think of. And it's easy to multiply, easy to work with. So the hypotenuse is 2 times that. So we'll call this one x. And then the long leg is radical 3 times that. So when we go to put numbers here, 2 times 1, that makes this 2. And that makes this one 1 times radical 3. So this is just a plain old radical 3. So I'm going to use the red numbers to fill in the boxes here. And so again, we have to look at the angle. So now the angles are going to change. The sine of 30 is opposite over hypotenuse, 1/2. I'm going to jump around, right? Because here is cosecant, so this is a 2. Cosine, I'm still on 30, and it's adjacent, radical 3 over 2. When we flip this over, we have to rationalize it, so it's just 2 radical 3 over 3. For the tangent, it's 1 over radical 3. Well, we can't have that in the bottom, so it's radical 3 over 3. When we think about flipping this over, that's easy. That's just radical 3. So now we're going to switch angles. And we're going to look at the 60. So now the 60 is our angle. I'm jumping all the way down to here. And so now this is the side opposite. So it changes. You change angles, it changes. So opposite now is radical 3, hypotenuse 2. When we flip that over, that goes with cosecant. This is 2 radical 3 over 3. What you should be noticing is that the answers are the same. They're in different spots, but they're the same numbers. Now we're dealing with adjacent. For cosine, that's 1/2. Cosine goes with secant, so that's a 2. Tangent is opposite over adjacent, so that's just plain old radical 3. And this is radical 3 over 3. So again, the relationship is the sine of one angle matches the cosine of the other. They're the same. Knowing these little tricks means that there's less numbers to learn, and it should hopefully help you kind of go through the unit circle. We'll go through all of this again once we get to the unit circle. This is kind of like a little preview. Now, in a 45-45-90, we only have 2 measures. The legs are 1, because they're both the same and they're both the shortest. And then you multiply by radical 2. So 1 times radical 2, so that's just radical 2. We don't have even less numbers here because there's just not that many. When we think about putting opposite over hypotenuse, 1 over radical 2, we have to rationalize that. So it's radical 2 over 2. So again, which 45 are you looking at? It really doesn't matter. I did opposite over hypotenuse. Now I'm going to do adjacent over hypotenuse. It's the exact same numbers. Tangent, it doesn't matter which 45 you're looking at, 1 over 1. Of course, the cotangent reciprocal. So when you think about flipping this over, that just makes these other 2 radical 2. You'll have some questions in your homework about these values. The answers are all right here. So just be sure to look at that if that helps you. And we'll go through this again when we do the unit circle.